So we will start in 2 minutes. Let's wait for others also. So I hope you guys read the instructions that I gave in Google Classroom. Like you have to just download that data set with you and just tell me once if you all are done. And after downloading it, just make a file. Like see, I am doing it in, I'm presently showing it in my VS Code. See, my idea was like you would be using Google, like that Colab for the time till now. But when you will go for some, hey, I guess I'm audible to all of you. Anyone's confirmed? Yeah. So yeah, when you will be going for some industry, like for some industry, or you will be doing some internship and anything, like if you will do some internship under startups, then they don't care much. But yeah, if you will do it in some good companies or something like that, then they will for sure, like they will ask for some particular like hierarchy of your that directory. Like they want many things in your directory rather than just having the code and all. Okay, so today we will have more focus on that. Like we will learn how to maintain everything. Okay, so but for the like initially I will be just doing, I will show you like others have done that EDA and model training I will do, and then we will just read somewhat about that, like how we should maintain our file when we are going for some industry startups and all. And then we will just have a little quiz, and then finally we will go for our that deployment thing. I will just give you basics of deployment. I can't teach you deployment also in such a small detail. So you all downloaded the dataset. Okay, so yeah, after downloading the dataset, see today we will not like you can go forward with your Google Colab. That is okay. I will show you the very like other methods also where you can code and you can do it. So first of all, like you must be knowing that you can do everything in your VS Code also. You need not to go to Google Colab or any other platforms like Jupyter. Like if you have everything downloaded in your PC, then you can go for that this VS Code also. other is Jupyter Notebook, and one is Google Colab that you are doing. Today, I will show you Jupyter Lab. Jupyter Lab, using Jupyter Lab, we will do. Like, you can do it in your Google Colab. I will show you other methods. That's why I'm using today Jupyter Lab. Okay, so keep it in your make your profile. So you make your directly like this, and such that you will have your data set in the data, and then I'm going to open. Wait, I will show you. So I hope it is visible to you. Okay. So here, the same file I have opened it in Jupyter Lab, and now we will make one file that for EDA. And one more file we will do. So you have all opened your Google Colab or Jupyter Lab or VS Code, whatever you are using. All of you, please open a file in it to write your code, and just tell me, okay, like we have less time and we have to cover many things. Do it fastly. I'm giving you 2 minutes, okay? So I hope everyone is done with it, whatever I told you. So now we will go. Now we will start the ED. Yeah. My screen is visible to you all now. That Jupyter file that I have opened. So I hope you guys have gone through the dataset once. Like in that you like earlier also you have gone through many datasets. So it is also similar. And basically today I have taken a little simple dataset only because we have less time and we have to learn many things. So initially I will just see whatever whenever we get a data, like the first thing that we should do, the very first thing that we should do, that we should first explore about that data set, like what this data set is about. Okay, and this information that when you are doing internship or anywhere in some company, then they will give you the internship, that the product manager or whoever, they will give you the domain specialist person will give you the information about your data set, that what all these things tell you. So being a software engineer, you need not to have information about everything, but yeah, the person who are with you, the domain person, they will give you the information. So that is very important thing. Before exploring any data set, we should have a basic knowledge of the data set, that what it is telling. So I will just paste the information, like there are many columns in that data set. I will paste the information about that data set here for you guys to go through once. So this is just the information about the data set. I guess you be been knowing about these all. So yeah, so now we will start. Okay, and today, like I guess I don't know how others have taken. Earlier you would be today I will be typing all the code, and I will be doing it fast so that you guys can also do. You can also do along with me. Okay, so it will not be a problem, and I think we will do it fastly. So it's first import. We have to import the important libraries. So obviously we are going to do EDA. So the first library that comes in our mind is pandas. We need pandas. So I will import that, and then obviously we have to load our data set. So what? See, I'm going very slowly. Please follow. Like you can write the code along with me. You will understand what we are doing. Okay. So do it along with me. So and I'm also sharing my thought process, like when we get any data set, that how I should proceed, like how I should go for the final, everything, that how we should do. Okay, and this data set has not much difficulty. So in EDA we will not have much problem, because like I have picked such a data set that we will not have much missing values and all those things. So because we have to learn, we have to focus on the model training and all those things. That is why I have taken such a data set. So yeah, so like as we got a data set, and we read about the data set a little, like yeah, these all are the information about the data set. Now what I will do, I have to go and do some EDA. So first of all, what I will do, I will be importing the libraries. The first library, very basic library that I'm going to import, is obviously the pandas. And then what I will do, before going for anything else, I will first load my data set. So I'm going to load my data set. And you have to, here you have to you have to write the path of your data set. So for me it is like this. So, and I guess you are also maintaining the same. And once we have our data set, we will first have a first look of our data set, obviously using like this. Okay, so we got the data set, and these are the ID, these are the columns, and these are the rows, the first 5 row I am showing you. And then what we do, like after having the data set, the first things that we check is whether the data set has some missing values or some duplicate values or not. So like it is not there, but still I will show you. And please do it along with me so that you can also see we don't have any missing values here. And then two functions are very important. First one, df.info and df.describe. I guess others would have explained you this. So sorry. So df.info, like this df.info gives us the information about basically every column, like what kind of columns are present with us, like floating, values, object, and all those things. And I guess you know very well that for training our model, our first priority is always to convert every column into numerical form, like in int or float, so that we can that is a very important thing, because the models are basically the form of like a mathematical, these all are machine learning models are mostly mathematical models only, and except some, like you can tell decision tree and random forest, they are also mathematical, but they have some trees kind of structures. So in that, you need not to even convert your that categorical features into numerical features, but yeah, you would have seen that everyone do it. So the reason behind that is simply because the libraries, that sklearn and all those libraries, they are designed like that. That sklearn libraries, they don't accept the even in decision tree or random forest also, they don't accept any categorical feature. But if you will code your random forest or decision tree kind of the trees kind of models by yourself, then you need not to even take care of about any categorical or numerical feature. But here, but except some, in all other data sets, we have to take care of it. And so our first priority is always to convert all our categorical features into numerical features. I guess they have uh, they have discussed these all in your EDA sessions. So let's move ahead. So this was just a simple like df.info we did. Now we will do df.describe. I can't do df.describe. Now, see, in this data set, I I am interested in predicting the price. Yeah, I have written it here. Like our target variable is price. So the thing that is coming in my mind right now is see what I can do. Like ID is not important for the price. Whatever ID, like whoever has collected this data set, he has kept some he had kept some ID and all. So we need not to predict. The ID does not play any role in predicting the price. So the thing that is coming in my mind right now is to first drop that ID, because that is of no use for me. So I will drop that. Let's drop it first and save up it in our dataset. After dropping that, let's see our data frame again. So yeah, ID is gone now. Now next what we can do, obviously the first thing that we saw is whether it has some missing values or not. So they are not present here. Now we will like I had told you, like we will go for the duplicate values. We will see whether we have duplicate values or not. So for that we have functions directly we can check. So yeah, it is coming 0, so we don't have any duplicated values. Now see, now what I have to do, see, presently I'm not doing the model training. What I'm doing the EDA part. So I'm interested in making some graphs and all, and take out some outputs, like what is there in, take out some insights from the this data set. So for that, the first thing that I should do, I guess I should do here now, that I should first segregate which all columns are numerical and which all columns are categorical. Okay, so we will go for, like, I will be doing that now. I will segregate the numerical and categorical column first. Yeah, I'm doing it along with you, so please do it along with me, because like, I guess through this way you will learn better. So please do it. Okay, let's check it. So yeah, I'm getting it now. Since I have segregated my columns, what I can do, like, I can, like, now I can use that describe function, because I have the categorical features and numerical features segregated now. So I will use that describe function for the categorical features. Okay, so I'm getting this. See, this is also an insight that you can write now, like using Markdown. You can write that this all I got at. It has and the top one is ideal, and the color, in color, it is G. This we can write in insights, but I'm not writing it. You can write it now. Now we will one by one go for the numerical categories, and we will see about some numerical categories. First, let's see about some value counts. Okay, for this I'm checking the value count. What is, okay, so I got the value count, and I'm just checking it. Like, see, these all things we do generally to get insights before training our model. We have to do all these things so that we will get an idea how we will be proceeding for training our model. See, here I'm getting that ideal category is somewhat like somewhere like 92,000, and premium is 49,000. We can tell that this is a little skewed towards ideal, but okay, it's a good distribution. We need not to do anything in that for during we will be training our model. And let's check other categories also. So for color also we will get. In color also the distribution is good, I guess. So we need not to do anything. Now we'll go for the next, clarity. Here also we have a good distribution. Like this we are, I'm just doing it to, like, during EDA we do all these things, information describe and all, so that we can get some idea about the data set. What is it now? Now we can plot some graphs. Like, obviously EDA is all about plotting some good graphs and taking out some insights. So I'm going to do that. First we will have to import the libraries. See, I was just writing the simple code, so like I was not explaining. I guess you all understand all these things. So let's do it. Let's see what happens. I'm trying to plot some graph, some hist plots and all. PLT. Okay. Yeah. So we are getting some graphs now. I just I just wrote a loop so that we can get all the graphs at once. So yeah, here I'm getting some insights from it. Like these insights you write by yourself. You have already done the EDA sessions 2 or 3 days, I guess. So like insights you can write. I'm just doing it in front of you so that you can have some hands-on with me. The insights you can write from here, whatever you are getting now. Now, what next we can do? Yeah, we can plot some correlation, some heat map. So let's do it. And these curves, I'm plotting it from only numerical columns, obviously. This correlation and all you must have read in our previous sessions. Okay, so I got here. Now here also we can see why these all graphs are important. So like these insights you should write by yourself, but okay, I'm just giving you one. So see, while training our model, what I will be like, what I'm here observing that see x, y, and z are too much correlated with each other, like 0.98, 0.98, 0.97, and here also. So during making our model, what we can do, we can. This is also one of our technique of feature engineering. Like rather than taking all these three columns, since these three columns are so much correlated with each other, we can just make these three columns into a one single column, and then we can further go for it, go for the model training. So this is one of the insight that we can take out from here. Other insights that you can take out, obviously, like which the price depends on that z value by 0.89 and 0.99. These insights you have to just take it out from here and just write it here once markdown form, and your EDA will be done. So not the after that, what we can do, we can check. Okay, we can just check it. Okay. So this is our data set. Now we will, and now like going for, like now I'm planning to go for the model training and all. So that is why I need to just once check what all things I have in my data set. For every column, what all things I have. So I'll be just checking every column, and that what unique values it contains. So for that, we can do it like this. So okay, for the cut, I have these all unique features. These all unique features in the whole data set. I have only these 5 or 6. Sorry, yeah, 5 unique features. Now for others, also you can see. So for clarity, we have all these features, and similarly for color, we have all these. Okay, so this I'm just getting the idea, like in every column, what all different kind of features we have. So just that I was doing. Now, see, now what I can do, like I guess this much. See, but the EDA part is not that much in this data set. So this much is sufficient. If you can, yeah, I guess this much is sufficient. So in the same way, like you can plot some other graphs also using one column and other column. If you will plot, then you will get some other graphs also. From there also you can take out some insights and all. So I guess, but for the timing, I'm just doing till here. You can write some insights from here. You can write many insights from here also. So we'll we'll go for the model training session. That is more important for today. So any doubt, if you want, you can ask now in this. I'm giving you 2 minutes. Those who are lagging, while writing the code. I don't think so. I am writing along with you, so you should not lag. So still, if you have any problem, then just ask it or write it in the box. I'm giving you 2 minutes. Model training also we will do together. So please write your doubts. And if you guys don't have any doubt, please uh, like send a thumbs up so that I can understand. Others, please. Likit has just done it. All others are done or not? Okay, Vanya is also done. Just do it fastly, okay? Within 2 minutes. Okay, I guess everyone is done. I hope so. Everyone is done. So we will go for the next part, and that is model training. Here, see, here what I will do. I will write the code along with you, and I'll be writing it slowly only, and will explain every line so that you can understand. And we will train the model. We will save the model in the form of pickle, and I'll show you how we. In the end, I will show you how like we use that pickle form to predict everything. So let's start it. Okay. Okay, then we will start. We'll again while whenever we are going to do anything, obviously the first thing we have to import all our libraries. So the basic libraries first I will import. And again, then I will be importing the data set also. We will see the data set. Sorry. Okay, so this is our data set that we were doing EDA. We have done very basic EDA, and okay, now we got it. Again, same thing. We need not to that. We need not to check not whether we have null values or not. But generally, when see, like I'm doing it EDA separately and model training separately, but this is not the way we do. Obviously, I should have done it in the same file, but I'm just separating it to make you understand very easily. Now, see, now I'm going for the model training. So what I need to do, I have to first I have to segregate those columns which I'm going to predict, and those columns which are the columns which will help me to predict my model. Firstly, I have to separate x and y values, and then I will go further. Okay, so the first thing that I will be doing, obviously, I will make two different data frames. The first data frame that I'm just keeping x, and what I will do, I will just drop the price thing from here, because the price thing we have to predict, so that will be our y value. So here I'm going to take it. Okay, so I'm going to drop that column. So price, I'm dropping it from x, and then from y, then y that the thing that we are going to predict. So that is our actually the price feature. Okay, so this is my x and y value. I'll be using this x and y. So I got two data frames. The first one is x, and that is without that price, and the second one is y. I'm just seeing it once. Okay. Now again the same thing that the same thing I have to do. I will be just segregating the numerical columns and the categorical columns, because before going for the model training, I have to do some work over categorical features. We have to convert it into numerical in some numerical forms. Like we will see how, we will finally analyze our data set, and we will see which method is best. Here, which method will work the best. So I guess I can do that. I am just going to do it. So I got two different columns, like numerical columns separately and categorical columns separately. Now we can, okay, I'm just giving some simple name. Okay, now. See, now I have numerical and categorical features separately. Let's see, first we have to treat with categorical columns. So we'll see. So I have these three. Now I have to do some, I have to see this our data set, and we have to decide at which method we will be doing. Like we have three different methods, and in simple we have three different methods. The first that you might have read in, that we have one hot encoding, and the second, we can go for ordinal encoding. Like for each different feature we will assign some number, and we'll further go for it. I guess in this data set we can go for that, because uh, that and apart from that, we have other way also, that label encoding and all. So here in each, like in cut, that is why I was doing this here. And then, like for every for cut also, I don't have much different values. I have 5 here, I have some here. So what I can do, presently I'm also thinking along with you, like we can go for for ordinal encoding, and we can try ordinal and encoding along with you. So yeah, let's go for ordinal encoding, and we'll see. Okay, so let's do it. And see, first, before going for that, what I'm like, you have to. If I'm just writing all those in once, so that I can get all the categories together, and I'm writing it in an order, like here. Here I have given the information about every category. See, cut is the quality of the diamond, and then color is the color of the, obviously, color of the diamond, and then what else? And clarity. Yeah, okay. Then clarity is, diamond clarity is a measure of the purity and rarity of the stone and those things. Okay. So I know, like, I want to put it in an order of decreasing quality or increasing quality. So I will put it in the order of decreasing quality. So let's do it. I just want to have all these in an order. Okay, I guess I have less time. Can what I can do. Yeah, this is the order. This is the order we have. Like for cut categories, we have fair, the best, and then good, then very good, then premium. Sorry, the fair is the least one, then good, very good, then premium, and then ideal. Similarly, these all are also this are the order in which I want. Okay, so I put it in the order. You can write it now. Okay, so overall, everything that we had to do with the data set, we are done with all those things. Now I should go for the model training and all. So what I was thinking, like I will explain you the pipelining concept along with this here. See, what is see like now I'm going for model training. Now imagine like you have created your model along with you by doing all these steps and then importing some libraries and all. Yeah, you created your model. Now you have to predict the value from that model, but you can always have this problem that when you are predicting, when you are directly, see what we do, we apply some our whichever models we want to, whichever like way, whichever mathematical terms like we want to use, we use it, and we finally make a simple file that is our model. Like for this case we will be making a pickle file, and using that pickle file, what we will be doing, we will be just giving it some inputs, all our column, like whatever columns we have, that all inputs we will give to that file, and we will get our out, like the price thing. So that is all. But just imagine, like if you are manually doing it all, imagine that this data set had some missing values in it, and you, while doing EDA, you remove those missing values, and then you went for this making this model and all, and you trained your model, and you got a pickle file, and now you can predict. Now you can always have that problem that while giving it the values, when someone is giving it the value, then he will be giving uh, some missing values while predicting. Like in the end, after doing all those things, when he is giving some values to predict it, then he might give you some missing values in that. Then your model will not work, because you have trained your model so that when it will get all the inputs, then only it will perform the output, then it will give you the output. But that is not always the case, because you can't always have all the values in your model, and like when you are giving some input, you can't always have all the values. So we have to deal with it. Like how we will be dealing it, like even when we will make our model, and if someone gives it some missing values in it, then how will you will make your model to deal with that. So for that, like very simple concept, like we use pipelining concept, so that, and using that pipelining concept, what we do, like using a function, we incorporate this missing dealing with this missing value and other things in our model itself, so that later on we will not have the problem. Okay, So for that, I will be now I'll be importing some libraries, like all the libraries that are required for that. So okay, so let's import all libraries. See, what is this function about? See, this simple imputer, what does it do? This simple imputer is used for handling the missing values in our pipelining. Okay, so simple imputer is a function that we use, like in sklearn it is defined. We use it for handling our missing values. The second thing that I'm going to import is standard scale. I guess you guys have used it in our previous session. Standard scale. This is used for feature scaling. And next we can do ordinal encoder, because we have thought that we will be using ordinal encoding here. So I'm importing the ordinal encoder. This all we will keep it in our pipeline, and we'll make our model. And next, what I can do, yeah, obviously pipeline. I'm telling you, I have to import that also. And now this one more function that we have to import. It's scalar.compose column and column transformer. Okay. See, like why not this column transformer? Why we use this column transformer? See, when I will be giving you this file, then I will add some comments over all these functions so that you can edit it and you will not forget. For the timing, I'm explaining you. See, this column transformer function is I'm importing it because it is used to it is used to apply different pre-processing steps to different columns. Like, see, I have one categorical column and then one numerical column. So the pre-processing step or the pipelining step that in our pipeline, you just imagine pipelining is just in real life we have pipes and all. So you just imagine that for different numerical category and for categorical category, we will be defining two different pipelines, and in that we will define some particular steps that whenever we get some input, we will have to that those all those input have to go through those all the steps, and then only after all those steps the output value that we will be getting, that only we will feed to our model or the pickle file that we will generate. So this all I'm doing it to make that pipeline. Okay, and this column transformer is used for segregating that to those uh, two different, like for numerical and categorical, two different pipelines. Okay, so basically in simple words you can tell it is just used to apply different pre-processing steps to different columns, that column transfer. And the pipeline, I already explained you that pipeline is used to streamline a sequence of data pre-processing, like a sequence we will make, and in that sequence only everything will be done. And ordinal encoder you already know. Standard scaler, you already know, like it is used for feature scaling. I guess you have done it in our previous sessions. And simple imputer, I told you, it is used for handling the missing values. So I guess all the libraries I explained you. We'll just see. Okay, wait. Yeah, now it's so I imported all the libraries. Now I will be actually making our pipeline. I mean, two different pipelines: the numerical pipeline and the categorical pipeline. I guess all of you are with me. So you all are understanding what all I'm explaining you. Just give me one thumbs up so that I can go ahead. Do it fast. Thank you. Yeah. Okay. Then now what I'm going that I was explaining you, the same I'm going to do. What I will do, I will make two different pipelines. The first one, the first pipeline that I will be making it is for numerical pipeline, and the second one I will be making it for categorical features. The numerical features will be dealing with whatever numerical features we have in our dataset, and the categorical features. See, for both of them, the way will be different, obviously. Uh, like how it will be different. See, okay, we'll discuss it further. See, for a numerical pipeline, we need not to go for the encoding process because numerical categories are already numerical categories, so we need not to encode it. But for categorical features, we have to encode it. And this all are the things that we do in EDA, or before training our model, we transform our model. But imagine like I have a data set in which we give input apple, mango, and all those things. So when a layman or anyone will be giving input, he will not encode it like we do, like the coders do. Like what you will do, you are a coder. What you will do, you will just assign mango one value, orange some two value, and other things. But the person who is giving the model input, he does not know that the mango you have assigned one or the orange you have assigned two. So we have to think in their way. They will be giving input mango and orange only. So you have to think that how you will be dealing with that process, that problem. So that problem only we are solving here. I will be making like here I will make two different pipelines, and in that I will use all those functions that I imported, so that even if he will give the inputs mango and orange and all those things, that mango and orange, all those things, that will be first converted into some numerical features. And if there is some missing value, then also it will do something, and then only it will be given to our model. So I'm doing that now. Okay, so let's do it. Numerical pipeline I will make. Here I will define the steps. Okay, so what all steps I'm going to do? So first, this is our numerical pipeline. So what is the first thing? What all I have imported? Yeah, simple imputer I have imported. Obviously, this is the first thing that we have to deal with the missing value. So I will be first dealing with the impute. I'll first import that imputer thing here. And simple imputer, and obviously all this have some like some factors that you can go for the documentation and you can read it. And here for simple imputer, we have to define the strategy. Now see, during like while doing EDA process itself, we think that what method we will be going for dealing with the missing value. You would have read it in previous sessions, and they would be teaching you EDA, that how to deal with the missing values. While dealing with the missing values, we generally deal it through three methods. Either we use mean value imputation, or we use median, or we go for some other methods. Okay, so here while doing EDA, what we had observed, like while doing EDA or by seeing this, we had observed that the all the values are not where it is. Yeah, here. See, all these values are not that much deviating from here and there. So we will have some central value. So I guess I can go with the median way. So I am using here median. Other methods can also be used. So strategy that I will be using here will be median. Okay. And I came to this conclusion that I will be doing median strategy here. Like wherever I will have missing value, I will put the median value of that column. This To this conclusion I came only after doing the EDA process that we did earlier. Okay, so for any new data set when you will be coming, you also have to think like this only, like how you will, like whether you will be using mean value imputation or median value imputation or whatever. So you have to think yourself using that data set or doing the EDA of that data set. You will get. And now the next function that we should do, obviously this is our numerical feature, so we have to scale it. That is why I have imported that standard scaler also. We'll be scaling in that tab. So yeah, standard scaler. And you have to define any strategies for that. So yeah, standard scaler. What else we can do for numerical pipeline? I guess then like no other thing we need to do. Now I will be making the categorical pipeline that I will give its name as cat. And again pipeline, and again in a categorical pipeline. See, in categorical pipeline now I can't use median strategy, obviously. Like see, I have categories in that. I have different categories, or it is a string value, so you can't do median of string value. So that's a problem. So you can't use strategy median here. So what's the other strategy that you can use here is in the strategies there are many other ways also, and in that we have this like most frequency. Obviously, this like this is when you will have all the string values, whichever string value is coming the most number of time, you can use that. And so I'm writing that whichever most frequent. And for knowing what all values that we can give it to, we can give strategy. You can go for the documentation. You will get it there, the pipelining documentation. You will find all the documentation related to that. So okay, so that is done. And that scaling also we have to do in. But scaling we can do. Oh, sorry. Scaling we can do only after converting our numeric or categorical values into numerical sum value. And for converting them in numerical value, we have to think of some way. And we have already came to this conclusion that we will be using ordinal encoder. So I'm going to use that. In ordinal encoder, I already. Okay. And in that, we have to define the categories that, yeah, okay. So categories is equals to, what all categories we have? Category, color, then color category, then Roman numbers. Clarity. So yeah, and once it is converted into some, see what this step, what this step that we have defined in our categorical pipeline, what this step will do, it whatever string value it will be, it will apply ordinal encoding. And now ordinal encoding I'm not going to explain. You have read it in EDA when we were doing EDA or whatever, in whichever session you would have done it. What is an ordinal encoding? This will apply ordinal encoding to this all categories, and then convert it into numerical category. And after that, then we will do the scaling process. Scaling process we have to do, obviously, like you would have studied it. Why? So I guess I defined our pipelines, numerical pipelines and categorical pipelines. Now, yeah, now I have to do, wait, first minute. Okay, so this we ran successfully. Now I will be using this function, that column transformer. I have to combine both these transformers to make a single pipeline. Okay, we will call it preprocessor. Okay, preprocessor, because this is the step that is being done before we are doing anything. So, column transformer function I'm going to use, and in the column transformer function, okay, I can define numerical categories, pipeline, numerical columns. Okay, these all are the arguments. You see, you can't do it by yourself. Obviously, you will have to read once the documentation. From there, you will get to know that what all arguments we give to column transformer and all. Okay, so don't worry about that. I guess I have written the correct. Okay, now this is done, and next I should give. I will define category and then cat. Okay, done. So this is our preprocessor. But like using this column transformer, as I had explained you earlier, that it will just combine both this pipeline, and I will get one common function that I will be using for doing the preprocessing stuff. Oh, we got something. Okay, yeah, wait, sorry. And this here. Yeah, okay, now done. Now this is done. Now the very common step that we will be doing: train test and split. I guess I'm doing it very slowly so that you can also do it along with me and understand it very nicely. And I will give all the arguments. Test size, like we can decide ourselves. So I'm taking it 0.3. 30% and random state you have to give random state. This I can give 42. Generally people do 42, but we'll do it 30. Okay. I guess that's oh. Then we got our all the X-train, X-test and all. I'm just, let's see them once. Okay, I got it. And now next what I should do, yeah, okay, now we will go for the model training. So we will be importing our models that we want to train. See which model we will be using here. That also is a very crucial part that we have to discuss, like which model we should go for. Okay, so obviously before going for anything, like before going for training, we have many options. We have many options with us. We can go for linear regression, we can go for decision tree, we can go for random forest, some other methods also. Like I don't know whether they have discussed it or not, but very simple: lasso regression, ridge regression, elastic net regression. This all we can use here. Okay, what I will do, okay, I will let's do all, and we will, and finally we will see like whichever model will have the maximum accuracy or maximum good metrics, we will use that. Okay, so I'm importing all the functions. Linear regression, we can import lasso also. Then we should use ridge. I don't know whether they have taught you this or not. Like lasso, ridge, and elastic net. These all are just some modifications in the cost function. If you will do then from linear regression, and then you get these all. These all are different models that we can use to train our data set. So you need not to worry about this. Elastic net, and what next we have taught. Okay, we will use decision tree also. I'm showing you all the like all the models that we can use here. Okay, and we will just compare that whichever model will have the best accuracy, we will use for training. We will use that model for training. Okay, I guess this is the last cell that I'm writing code. Learn. Okay. And now we will import our what metrics scale on dot. I guess metrics session you have done, so you will be knowing this mean absolute error, then mean squared error, and then R2 score. R2 score is important for us here because we are using this linear regression last one out. So R2 score is an important metrics that we are going to use. Now what I will do, now I will define all these models. Okay, so let's define our models. First I will define linear regression. And in that I have to call the linear regression. Okay, now done. What next I have? Lasso. Then I have ridge. And then elastic net. Elastic net. Next, yeah, this is entry. You can use other models also, like, but I guess this 5 models, I will show you using this 5 models. You can try other models also on it. And okay. This is entry classifier. Done. So this all are the models that we will compare and we'll see the accuracy. Okay. Now, okay, I will make a list of it. I have to train them all. So yeah, let's make a list. Okay, and what is our model list? That also I have to define so that I can automate it. Now, our R2 scores. This all list I will be using for comparing. I'm just making 3 lists. So why I'm making, you will understand it. Like I am going to make a. Okay. Now let's define a function. This function I'm making it for evaluating the accuracy of all our models together. So I'm making a function so that we can get our accuracy together. So for that, what I will be needing, I will be needing 2 values: y test value and y train value. Oh, sorry, y test I got and y train. Y sorry predict. I have defined it out. Okay, I'm just writing it here, and then it will have some 2 inputs in it, and it will be making it will give you our metrics. Okay, so I will call the mean absolute error, and then I have to give that 2 values: y test, y prep. Okay, done. And and then Okay, MAE, and then I have MSc, and then R2 square. Sorry, RMSc. And then here I will be using R2 square. And this all three I want, so here I will define R2 square. And square. Done. So this all will be the things that I have to do using this function. Now the return, what it will return. It will return ME value, and then it will return RMSC, and then it will give us R2 square. R2 square. So that's it. So these all are the, like, I just defined a function to give us some. Now I will make a loop so that I can use all the models together and do it. Okay. So for this loop, I'll have model name. I guess this all you understand. Like, I'm just writing code. Like, see, first before going to do anything, you have to first fit the model. So I'm doing that thing here. Okay, this is done. Now next, what I can do? Yeah, I have to make y predict the value that will be predicted. So y pred is equals to and I have to give x test value inside. Okay, and done. So now I will be evaluating using that functions that I made, and I will get MAE, then RMSC, and then I will get R2 square. And this all I'll get from that function. So we defined evaluate model and give evaluate model, and I will give input as y test and y pred. Okay, y test. I hope you understood. Now, okay, let's so that we will understand it. Model name. Then I can do model list. Model list.append. Model name. Okay, done. Now let's just. I guess all our works are done, and I'll be just printing the values, whatever I want to print. Model this what three values we want? RMSC. Just a minute, just a minute. Okay, so model training performance system, RMSC. Yeah, multiple. Yeah, RMSC. and here or to school. R to square multiplied. We have to get it in percentage. We will multiply it with 100. Now I will just append that value. To this dot append. And just to separate it, I will just print 50. Change that. I guess I wrote all. Okay, so I wrote all this, and we can, I guess I automate it all so that we can get all the performance metrics of all the function, all the models once. So let's see it where we got mean, absolute error, absolute error, and ID. I don't know what error. Okay, wait. I have not given maximum date. Yeah, and then I'm getting some error. Okay, wait, I have just left one step after importing. Yeah, we have to make the data frame of it. So, okay, wait. Like I didn't even get the functions that I was defining here, preprocessor and all, the pipelining and all. I didn't even use that and directly did all. So that is why we were getting the error. I guess let's correct it. Transform extreme. Preprocessor and sub. Okay, so decide it and then X test. Similarly, I will just have to remove the fit. Oh, sorry. Transform. Then extreme X test. Just call this preprocessor. Okay, so now I can just restart my. Let's see. Oops. So okay, now we are getting the output. See, I had forgot this step. Like I had defined all the functions, and I didn't even give it to that. So now I am getting all the values for linear regression. See, I will be comparing R2 score most probably here, like because these are linear functions, and like R2 score values the most here. So RT score I am getting for linear regression, I'm getting 93.68. For lasso, I'm getting 93.68 again, but 93.689 and 409 whatever. For lasso, we are getting this, and for art for this ridge, I'm getting 90 this, and for elastic 85.5, and decision tree it is still working over decision tree. So this tree will also come. By the time we can go for the. Now what next I have to do? I will be making the pickle file of it. So I'm going to import pickle file. So now see, once I have got all the R2 scores of all the models that we are using, I have to compare, and then I have to make the model from it, and so that a model that we can save it in our hard drive, and we can use that model for training for predicting all our outputs. And we have used that function also. Sorry, the pipelining concept also, so that if you are since you are using pipelining, so we will not have much issue, because even if you will go give some other values, then we will it will deal with it. And here what happened? Okay, that's the problem, because maximum depth is 100. Okay, I'm using it in my Jupyter lab, and it does not have space. Okay, leave that decision tree. Will I don't have space that much. That's why that decision tree, because in decision tree you make too much, trees and all. So the depth will be too much. So that is why that is not able to assign that byte that much. Okay, so I will remove it. We will compare from all the others. We will compare from all this code. But decision tree will also work. Like if you are using Google Colab, then I guess it will work here. Like here in my PC, it is not working. We will move further. And now what I'm doing, I'm going to do. I'm going to make the pickle file of using all this. See, we have using Elastic net, we have 85% only. So that is not a good accuracy. And then linear regression, you have studied linear regression, and we have 93.69. And I guess for all these three almost equal, so we can use anyone. We will go for a linear regression, and let's make the pickle file of it. I guess I just need to write a very simple 2 cells code, and we will be done. So let's make regression. Dot fit, and I have to give input as xtrain and xtest. So xtrain and xtest. Sorry, ytrain. Now, like the same process I'm again doing, but since we have this line of code, I have just written it to make you understand that like we can use many models, and whichever will have the highest accuracy, we will use that further. So I got to know that like linear regression has the highest accuracy. So now I will make my file using that linear regression. So I'm using that now. Pickle, and this pickle is a function that we are importing it to make a standalone file that can be used for the predictions. Okay, so that is just like I will just give it a name. What name should I give? Linear regression. Model.pkl. And what I have to do, I have to open this file. I have to open this file in write mode, and then I have to dump pickle dot linear regression model file. Yeah, and then I will just print. Sorry. I guess we are done. Pickle important linear regression, and then that's it. Okay, so it told me that the model saved to linear. We should get our model, and it will be saved here in my directory. So I'll just refresh it. Yeah, we got it. Okay, so I got this file. I can't open this file obviously, and this is of different format. So, but let's see. Okay, this is for different format. You can open now. This like if you will learn in if you will do it in your, you will get a .pkl file. You can just see the see the information. See, the name is linear regression model.pkl, and this is the file that to which you will be giving the input, and it will give you the output. Like obviously you will tell that let's see it, like whether it is giving us the output or not even. So I will give I will just test whatever I have the x test value. I'll just test it, and I will I will find out the output of this, and this is the last line that I'm writing. Okay. So now I need to open it in read mode. Obviously, previously we were writing it. Now we are opening it in read mode as file, and then maybe we will have to load the model. Dot load file. Okay. I open the file, and then I have to give y prediction to the loaded. Okay. Loaded model. Test. Okay, done. I guess I should get what I am doing now. I have made our .pkl file. Now I will use this .pkl file to predict the output. And see, for our training, I had used xtrain dataset. So now I'm using like xtest dataset to get the output, and I'll see what output I am getting. I guess I have written it all correctly. Open .pkl. Okay. Okay, yeah, I got the outputs. So these all are the outputs, like this values for every x test value. I'm getting one output value. So our model is working fine. And we what the model we have used? We have used linear regression model. Like we can use other, like you can use ridge model also, and then also you will get a file and you can do it. So I guess model training is all done, and I went very slowly. I know I took much time. Okay, I hope you all understood. You all understood, then give me a thumbs up. Or you all are done or not? Yeah, okay. Okay, thanks. All of you are done. See, I have used only these four models. You use other also, like I was trying decision tree, but like okay, I got some error. You try random forest also, and logistic regression also you can use, and just put that name here, and in this model, put that name here in this model, and then you will get some outputs of it. You will get some scores of it, and you can make the model using that also. Then you can compare all the R2 score, and you can go for the best model. I guess you will get linear regression model only best one. I have tried it earlier, so that is why I'm telling you. So this is done, and okay, so let's do that quiz thing first, because I have already taken too much time. Okay, I'm putting a link in the message box. You just go through that link and uh, give the answers. Just write the answer or the option. Okay. Go through it and just write the options, the best option. I have put, okay. You have 10 to 15 minutes. Just do it fast. There are only 8 questions, so you can do it very fast. 10 minutes is sufficient, I feel. So all of you, please submit it and you can go now. I was telling you initially that I will explain AWS deployment also, but I took too much time while writing the code. We went through some errors, and that's so we'll do it in some other session. If I will get time, I will come and I'll explain you AWS deployment, and I will show you some of my projects also that I have deployed. And so please submit the form and yes, okay. I'm still waiting for 1 or 2 minutes. Do it fast, please.